Hello everyone, and welcome to today's presentation. I'm excited to have you here as we explore gate valves, the workhorses of water distribution. In this session, we'll discuss how these vital components control water flow, their importance in infrastructure, and what makes them so reliable for maintenance and operational control. Let's get started and dive into the world of gate valves. Now let's look at how gate valves operate. When the gate seats firmly, it effectively cuts off the flow completely, much like a gate in a fence. This ensures a tight seal when the valve is closed. For multi-turn operation, the valve requires several revolutions of the handwheel, which actually helps reduce the risk of water hammer, a sudden pressure surge that can cause damage. When the valve is fully closed, the gate withdraws entirely into the valve bonnet, leaving an opening that's just the same size as the pipe's diameter. This design minimizes flow restrictions and keeps pressure drops low, maintaining efficiency. And when the valve is fully open, the gate is completely withdrawn, allowing water to flow freely through the pipe with minimal resistance. Understanding these key points helps us see how gate valves are effective for controlling flow, especially when we need a reliable, tight seal or a fully open passage. It's all about how the gate moves and how that movement impacts flow and pressure in the system. When the valve opens, you'll notice the stem rises visibly, giving a clear indication of its position. This is especially useful for quick visual confirmation. These types of valves are typically fixed to the gate and are commonly used on fire lines or above-ground installations where easy access and visibility are important. Now, moving on to the rising stem, also known as OS&Y, or outside screw and yoke. In this design, the stem moves up and down with the valve, making it easy to see whether the valve is open or closed just by looking at it. On the other hand, we have the non-rising stem. Here, the stem stays stationary during operation. The threading is internal, which makes this design ideal for underground installations where space is limited overhead. This design is most common in waterworks, where durability and space efficiency are key. So, in summary, we have two main stem designs, rising and non-rising, each suited for different installation needs and visibility requirements. Both are essential in our overall understanding of valve types and their applications. Let's take a closer look at some of the essential applications for our valve solutions. First up, knife gate valves are particularly effective in handling dense fluids and suspended solids, which are common in industrial water and sludge applications. They are designed to handle challenging conditions where other valves might struggle. Moving on, in wastewater systems, these valves serve as crucial shutoff devices. They help control the flow and ensure safety in fire protection systems, as well as manage the main water supply to buildings. Their reliability is key in these critical systems. In fire mains and services, these valves are the most common type used across many communities. They play a vital role in delivering water efficiently and reliably for fire protection and emergency response. When it comes to distribution networks, these valves allow us to isolate specific sections of the system. This is essential for maintenance or emergency repairs, as it enables us to work on parts of the system without disrupting service to large areas. They're especially critical when dealing with pipe breaks or system upgrades, helping us keep things running smoothly. Overall, these applications highlight the importance of choosing the right valve for each specific need, ensuring safety, reliability, and efficiency across water and wastewater systems. Let's talk about what happens during a partial opening of a gate valve. When the valve isn't fully closed or fully open, high-velocity fluid can pass through the partially open seat. This creates a sort of cutting action that erodes the seating surfaces over time. As a result, the valve loses its ability to seal completely, which can lead to leaks or reduced efficiency. It's important to remember that gate valves are designed strictly as on-off devices. They are meant to be either fully open or fully closed, not used to regulate flow. Using them for throttling or partial flow control can cause damage, like what we just discussed, and ultimately shorten the valve's lifespan. This limitation is critical because it impacts how we operate and maintain these valves. Ensuring they are always used correctly, either fully open or fully closed, helps preserve their integrity and ensures reliable sealing. So, always think of gate valves as the ultimate switch, never as a flow regulator. Let's talk about some common issues caused by buildup and corrosion in cast iron components. Iron oxide buildup, for example, can significantly reduce the capacity of the valve and even cause internal parts to jam due to chemical corrosion. This is often seen as tuberculation, which typically occurs at the stem, especially if the packing is worn, at the sealing surface if the wedge or seat are damaged, or at joints if bolts are loose or gaskets have failed. Moving on to leakage issues, these usually happen when the stem isn't properly lubricated, or if the stem is bent, or if debris gets stuck on the threads. All of these issues can make the handwheel feel inflexible and difficult to turn. Then there's the problem of difficult operation. Sediment, debris, or corrosion buildup can physically prevent the gate from moving smoothly. And of course, underground moisture can accelerate rusting and cause parts to seize up entirely. Finally, one of the most frustrating issues is when a valve gets stuck either open or closed. This can be caused by any of the factors I just mentioned: corrosion, debris, or mechanical wear that prevent proper movement. Recognizing these common problems helps us understand how to maintain and troubleshoot valves more effectively in the field. Let's take a closer look at some common leakage points and what causes them. First, we have joint leakage, which often results from loose connection bolts or damaged seals between the body and the pipe. When these components aren't secure or if the seals are compromised, fluid can escape at the joints. Next, there's leakage from the sealing surface, which can happen if the wedge and seat surfaces become damaged, pitted, or fouled with debris. This damage prevents a proper seal from forming, leading to leaks. Lastly, stem leakage typically occurs when the packing material around the stem is worn out or if the gland nuts are loose. This allows fluid to escape along the stem. Recognizing these specific points helps us understand where to focus our maintenance efforts to prevent leaks and keep the system running efficiently. Now, let's move on to some best practices for maintaining our valves effectively. First, when storing new valves, ensure they are stored with the gate in the open position, covered, and kept clean. It's also important to protect rubber components from UV radiation and debris damage, which can cause deterioration over time. Next, for stem and packing care, always tighten the packing gland nuts sufficiently to prevent stem leakage. If you notice any worn packing material, replace it promptly to maintain a proper seal and avoid leaks. Regarding flushing and cleaning, regularly flush the pipelines to remove any sediment buildup. When disassembling the valves, thoroughly clean the stem, threads, and packing areas, and remember to relubricate everything afterward. This helps ensure smooth operation and longevity. Finally, it's good practice to operate the valves at least once a year. This regular exercise helps detect any malfunctions early and prevents the valve from seizing. When opening, stop about a quarter turn back from fully open to avoid jamming on the backseat. All these steps are crucial for keeping our valves in optimal condition and ensuring reliable performance over time. Let's talk about the benefits of multi-turn operation. By creating gradual flow changes, it significantly reduces the risk of damaging pressure surges, which can be quite harmful to the system. This smoother transition helps maintain system integrity and safety. Moving on to water hammer prevention. When properly maintained, these valves provide complete shutoff capability. This is crucial for controlling the system effectively and ensuring safety, especially during shutdowns or emergencies. Now, regarding reliable isolation. When the valve is fully open, the opening matches the pipe diameter exactly. This design ensures minimal resistance and pressure drop, allowing the fluid to flow freely without unnecessary restrictions. All these features, gradual flow changes, complete shutoff, and full-bore flow, are key advantages. They work together to improve system reliability, safety, and efficiency, which ties back to our overall goal of optimizing system performance. Now, from mainline isolation to fire protection, these workhorses, meaning the valves, play a crucial role in ensuring safe and efficient water delivery to communities everywhere. Gate valves are at the heart of water distribution systems worldwide. They're highly valued for their full-bore flow path, which allows water to flow freely when fully open, and for their ability to reliably isolate sections of the system. However, it's important to remember that gate valves aren't designed for throttling or controlling flow. Trying to do so can cause damage. That's why proper operation and regular maintenance are essential. This all ties back to the foundation of water infrastructure. These components are vital for maintaining reliable, safe water supply systems that serve communities day in and day out. They might seem simple, but they're truly the backbone of effective water management.